Hey everybody, we're going to get into the second part of graphing exponential functions. In this lesson, we're going to actually apply the transformations. Now the good news is these are the same four transformations that we did earlier in the year in the second half of our first unit when we were doing transformations on a whole bunch of different functions. This time we only have to do it on one function, but it's the same transformations, and it's the same four transformations that apply to any two-dimensional function. All right, so let's go through them. So basically you start with some function, right, where b is the base, right? And this is where it gets tricky. When we get into them, we have to identify that base first. What is that? So in other words, the base is what is the exponent on. Notice how the exponent here, right, is on that base b. All right, so the b is not any part of the actual transformation, okay? The b is just the base. It's a, k, d, and c are generally the letters we like to use for our four transformations, right? It could be any letter, but there you go. All right, so let's review really quickly what do those four transformations look like and what do they do? All right, so let's start on the things that affect the y coordinates. What affects the y are the a and the c, these two here. So they are, notice how they're outside the function, right? The things that are inside the function are the k and the d, everything up here on top. Okay, so the things that are outside the function generally are what affect our y coordinates. So a times y is what a does. We multiply all our y coordinates by a. They cause a vertical stretch. So there's a couple things here. First of all, they cause a vertical stretch, and I'm just going to write, well, I'll write it out, but you can just use VS when you're doing your homework. Vertical stretch, okay? But for short, I'm totally cool if you just write VS, okay, for when you do your homework, because we want to be able to scribe them, but all you have to do is write VS. By a factor of what? That's the question. So by a factor, meaning we're multiplying, right? That's what factors are, of a. So we got to state what that is, okay? So what does that kind of look like, right? It basically means, I'm going to draw a quick little graph here. So, oops, there we go. Okay, so here's a little mini graph I'll squeeze in. So let's just say that this is my original function, right? Let's say it looks like this, right? Well, that stretched one will either make it like this, pulling it up vertically, right? Or if it's a number that's between 0 and 1, it can compress it down like this, okay? All right, so that's the first thing it can do. The second thing a does is if a is negative, so if a is less than 0, a negative number, there's a second transformation, okay? It causes a vertical reflection, okay? And you can just write VR for that, vertical reflection. So in other words, let me just write this here. So this is an important sheet to maybe write down, take some notes on, okay? Because really knowing your transformations well is really important, especially if you're going to grade 12 functions, okay? So it reflects down like this, right? So it uses the x-axis like a mirror, right? And it reflects down, okay? So that's what a does. The other thing that affects y is c. So that's one of the last transformations I usually do. But we take what we did to y, which was a times our y coordinates, and then we add c to them. So now c could be positive or negative, but what that causes is a vertical translation, which is a fancy way of saying moving up or down. And I don't like to use the word shift because we're already using stretch and the S's get confused, and translation is kind of the fancier, more, not accurate, but just the more common word you'll see. Vertical translation. So you can use VT, and then we just got to say, well, where is it moving? Up or down? How much? And we just write C, how many units? C units. So maybe it's 5 units up or 6 units down. So again, what would that look like, right? Let's say we've already done our stretch here. Let me just, let me just move this up just a titch. There we go, so I have a little more room. All right, so I know I'm really squeezing in here, but let's just say that this was my original function here in blue. Well, the vertical translation means we're just moving everything, taking all those points and either moving them up like this, or we're moving them all down like this, right? It's just taking what we did up here and then moving everything. So we're not multiplying, we're just adding the point to the points, moving them up, or subtracting from the points to move them down. All right, let's move on with k now. K, now this is where we got to get careful because things are kind of a little bit opposite. The k and the d are what affect the x. So whatever k is, we actually multiply the x coordinates by 1 over k times our x coordinates, okay? So what does that cause? That causes a horizontal stretch. All right. And you can, again, just write HS if you like. That's absolutely fine. Like whenever I do tests or quizzes or homework, that's 100% okay. You won't lose marks. If you feel like writing it out fully, feel free, but you don't have to for me. All right, so for example, let's just say this was my original one. Let's say it looked like that. Well, a horizontal stretch would pull it out like this, right? Now, if you look, that kind of looks like compressing it this way up here when we're looking at the vertical run, right? But a horizontal stretch is pulling it this way, right? Stretching it that way. Or it could be compressing it by pushing it like this, and maybe it looks more like this, right? So that's what we mean by that. Now, generally, to be really technical, if it's being squished, we call it a compression. If it's being pulled, it's called a stretch, but you can use the word stretch for everything. But if you really want to be technical, it's a compression when it's being squished in like that, okay? But most of the other teachers that I've been around have all just kind of given up on being super technical and have just stuck with the word stretch. But it's really a stretch or a compression, okay? All right, so the other thing you can say that this, if it's negative, right, what ends up happening, so if k is negative, so again, if it's a negative number, you see a negative out front, what that causes is a horizontal reflection, okay? So what does that look like? Sorry, and again, you can just write HR for that for short. What that does, I'll just draw this one in orange here, is it reflects it this way, right? Horizontally. It uses the y-axis like a mirror, right? So it flips it this way. All right, so basically everything that's positive becomes a negative. All the points that were negative become a positive, so it ends up just flipping it like that. All right, and the final transformation we're going to talk about is you add d. Now, you got to be careful here. One thing before I even get into that, you always have to make sure that this is factored. Notice how it's factored, the k is factored out. And we'll get into examples. And every time you do, double check that. So make sure it's factored and it's x minus d. So like if you have x minus 2, d is 2, not negative 2, right? So just be careful with that. And we'll see a bunch of examples. All right, so this basically does the same thing. It's a translation, but it's a horizontal translation. All right, so you're moving things left or right. Horizontal translation, left or right. Okay, you can just write HT and then just state which direction it's moving, left or right, and how many units. So D, whatever the number D is, so 5 or 2 or whatever. Okay, so again, that moves things left or right. So if I was to draw just a real quick sketch of that, let me just squeeze one in here, right? Let's just say this was my original graph, right? There it is. Well, if it's a positive value for D, it's moving it this way. It's kind of hard to tell, but the idea is everything's been shifted to the right. Or if it's been shifted to the left, it looks kind of like this, right? It moves things this way or this way. All right, what's the other important information we got to know about? All right, domain, range, let's talk about that first, okay? The domain. The nice thing is x can be any number, right, for any of this stuff. So you don't have to panic about that. The answer for all these is going to be x can be any real number, right? Real, that's why we use r. So when we say x is an element of r, means x can be any real number. The range, we got to be careful. The range, the y's are either greater than or less than whatever c is. So if it opens up, in other words, if a is positive, right? Remember that a from our quadratics, from everything, right? If it opens up, so if it looks like this, right? Because a is positive, then your range will always be y is greater than c. But if it flips down and it looks like this because a is negative, okay, then your range is always going to be y is less than c. So whatever c is, because look, let me just kind of look here, right? C tells us how much we move up or down, right? And the a over here tells us whether we flipped or not. So that's how you can figure it out really quick. You can also just look at your final graph to determine it, but you can figure it out just immediately. So when we do some of these, I'll show you how you can immediately figure out where your domain and range are, okay? All right, last couple things, the asymptote. How are we gonna get the asymptote? The asymptote is that horizontal line, right? Now, that's the first thing you wanna draw on your graph. Okay, and it's always y equals whatever c is. So whatever c is, that's where that horizontal line is. And again, we'll show you when we actually do the work. How do you find your y-intercept? Remember, it starts at 0, 1, but when you transform it, it's going to move. So how do we find that? How do we always find our y-intercept? For every graph since we've been in grade 9, right? You always set x equal to 0, solve for y. So sometimes that's a really important point, so that's why I want you to find that, okay? So set x equal to 0, and then what's the y coordinate. That's all you do. So just sub it into your equation. Now sometimes when you're doing the transformations, you might come across it and you don't have to do that. You'll have it automatically. All right, so let's get into some of these. Okay, so I'm going to do a whole bunch of these. Like I'm going to do 5 of them. Now, if you feel at any point after the first 1 or 2 that you've got this down pat and you want to just move to the homework, go for it. But I want to be really thorough because I'm going to let you know all the homework ones after the first one really follow closely along with each one I do after it. So if you want to kind of follow along as you do the homework, it's going to be very similar because I really want to make sure you feel comfortable with doing these. So you have a lot to watch. If you feel like tuning out after a while, go for it. All right, so here we go. What do we need to find first? Okay, so here's the function, right? This guy right here, f of x, there's the function. First thing we got to identify is what's the base. The base is what the exponent is on. The base is not -3, the base is 2. All right, so I want you to be able to identify the base function. So in this case, the base function is 2. All right, so why don't we find the why don't we graph, I should say, or not, we don't even have to graph it, but we have to make a table for the base function. So you need 5 key points here. Sometimes you might even want a 6th one. So in other words, you definitely want to know when x is -2, -1, 0, 1, 2, and sometimes you might even want to go farther in the positive. So if you find that you could use an extra point or 2, add it to your table. So like for example, I'm going to add 3 in here, okay? And maybe you can even go to 4 sometimes, you'll find. But you definitely need at least these 5 to start, but generally you might need an extra 1 or so. All right, so let's go through it. What's 2 to the power of 0? It's 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. And 2 to the -1, now you can use decimals for these, feel free, right? Remember, 2 to the -1 is, let me just write it down and remind you, right? This would be 2 to the -1, which is 1/2, which is 0.5, right? And 2 to the -2, which is 1 over 2 to the 2, which is 1/4, which is 0.25, right? Okay, so this is your starting points. Now, I'm calculating them over here, right? All I'm saying is what you need to know is use these as like your starter points, okay, for x. The y's, you'll have to actually calculate them, okay, based on what the base is. And like we said, in this case, our parent function or our base function is y equals 2 to the power of x, whatever that number is, okay? All right, now what can we identify right away? Before we even get carried away doing anything else, right? We can do all the transformations, we do all kinds of stuff. The first thing I like to draw on is my asymptote. Or, you know, even before we do that, let's identify a, k, d, and c. Let's do that first. So what is a? A is -3, okay? What is c? C is 7. All right, so we can take care of those, okay, first. All right, so what do those tell me? Well, if a is negative, it tells me there's a vertical reflection, so I'm just gonna write VR, and there is a vertical stretch by a factor of 3. All right, so that's basically as short as it can get to get full marks, right? All right, what about the C? What does that tell us? There's a vertical translation. Since it's positive, we're gonna go up 7 units. All right, so you know what? Let's find those y coordinates right away. Why not, right? So here we go. First we start with our stretches. So a is -3, so we're gonna multiply all the y coordinates by -3. So I'm gonna take all of these here and times them by -3, right? So I just don't have this table down next to it because I don't have a lot of room. So normally I put the parent function right next to it, okay? So we're gonna take these ones here, the y coordinates, and multiply them all by -3. And again, if you're someone who likes to do all the transformations at once, you like to do this and this all at once, feel free. I just like to break it into 2 tables of transformations. If you want to do it in one, that's fine. All right, so what's 3 times, 0.25? That's -0.75. Oops, boy, oh boy, I'm messing it up here. -0.75. All right, and then we got -1.5, then we got -3, -6, -12, and -24. So I don't know if that guy's gonna fit on the graph, but we'll find out. And then what do we have to do? Well, we take what we just did to the y's, we multiply them by -3, and we're gonna add c, which is 7. So let's add 7 everything. So when I do that, I'm gonna get 6.25, 5.5, 4, 1, -5, and yeah, this guy's not gonna fit, right? Because we're at -17. Now sometimes it can and sometimes it can't. So like that last point there, like I said, sometimes you really need it. You might even need another one. Sometimes you don't need him at all because he's clearly not gonna fit, but that's okay. All right, so we got those out of the way. What else can we get out of the way right away? Now that we've identified what c is, remember our equation of our asymptote is y equals c. So it's gonna be y equals 7. That has to be graphed on the graph. So I kind of got a list here and it's on your handout of all the important stuff, right? So identifying the base, making a table of values, doing your stretches. We're kind of jumping around here. Make sure you draw the asymptote, y equals c, okay? So draw that line in. That's the line that your graph will not touch. It can't cross it. It can't touch it, right? It's going to get infinitely closer to it as the numbers get smaller and smaller and smaller. So there it is. So make sure you draw that line. Make sure you have arrows on it. Make sure it goes right through the graph. And it's y equals 7. All right, now our graph's going to be below that because we had a vertical reflection, right? Normally it's above, right? But then it flips below and then we moved it up. So it's going to be below that line. All right, let's get into the x-coordinates now. The x-coordinates, okay, so we got to identify what k is. Now, here's where we got to be careful. Remember that thing where I said, and I got the hint there in each one, don't forget to factor the exponent. So this, when we factor out this, it's actually going to be 2 times x minus 3. So k is 2, right? And remember, we're actually multiplying by the reciprocal of that. So we are going to have a horizontal stretch. It's not negative, so we don't have to worry about a reflection, by a factor of 1/2. Okay, so we're going to multiply all the x-coordinates by 1/2. So let's do that. 1/2 times x. All right, so let's multiply all of these x-coordinates here, these guys, by 1/2. Right now, you're going to get decimals a lot with these graphs, so don't panic. Some of them are going to get really nasty, and you're going to say, well, how can I possibly graph that? Is Coulter out of his mind? Just do the best you can to graph them, you know, the best you can. Again, they're really ugly numbers, a lot of them. These aren't too bad, but here we go. Let's do 1/2 of each of those. So I got -1, -0.5, 0. Oops, I'm kind of making a mess of this. I'm trying to go too quick. I'm trying to move quick because, like I said, I'm going to do a bunch of these, and it's going to be pretty long. But I want, for those of you that want a lot of examples, I want to make sure you get a ton of them, okay? Because we're not in the classroom, obviously, right? And what did we say? And this is 1.5. All right. So I'm just doing 1/2 of all these x-coordinates up here, all right? All right, now the last thing is d. Now let's be careful, right? d is not 6. d, I know I'm kind of squishing stuff in here, is +3, right? Because we have to factor it, right? If you're like, wait, why was that again? Look at this form right here. I know I've drawn all over it. Just going back to the start, right? This is the key right here, okay? Look, it's k times factored x minus d. Notice how the x minus d is in brackets, right? So just going back to what we're doing, you have to factor it right there. It wasn't factored for you, and that's very common that it comes unfactored. So we got to factor it, and all 4 of them that I'm giving you in your homework all have to be factored, okay? So just be aware of that. All right, so what are we saying now? d is, now I'm lost. d is 3. So that's a horizontal translation. Since it's positive, we're going to go to the right 3 units. All right, so we just need to add 3 to all those x-coordinates. So take what we did here and add 3. Okay, so let's just add 3 to all of these transformed stretched points. In fact, these weren't stretched, they were compressed, right? Because they got smaller. So even though I said stretch, that kind of drives me nuts. It's really a compression, right? Because they got smaller, not bigger, right? The x-coordinates went from here to here, they're shrunk. So if you really want to be technical and fancy and show off, use the word compression. I'll accept stretch totally because that's what I've been using, but it's really a compression. All right, so now we got to add 3 to all of those. So -1 plus 3 is 2. Let's just keep going. 2.5, 3, 3.5, 4, and 4.5. And again, this point's not going to fit on our graph, but that's okay. All right, so let's plot these points and see what we ended up with, okay? All right, so I'm going to draw my graph here. I'll just draw it in red. All right, so what do we got? 2 over, this is where it gets tricky, 2 over 6 1/4 up. So again, I'm just going to kind of put a dot right there, just getting as close as I can. Let's do, what's the next one? 2.5 over, again, it's really messy, right? 5.5 up, right there. Oops, there we go. What's next? 3 over 4 up, that one's pretty easy. 3.5 over, 1 up, and then 4 over 5 down. And then this next point is way far down. But that tells me when I connect the dots, I shouldn't be crossing 5, right? Or 4.5, because 4.5 is like here. I shouldn't be crossing 4.5 to way down here. So really, it almost starts to look like a vertical line. It's not, but it'll appear to the eye like it's turning into a vertical line. So we should really just be, if we want to be really technical, right, we should just kind of be doing that. Make sure you go off the graph. Now, what about our y-intercept? Well, we didn't find that. Like, where is it over here? It's probably going to be right about there. But if you're looking for the y-intercept, how do we find that, right? Let me just make a little quick note up here. In order to find your y-intercept, you just set x equal to 0. So let's just take this original function here and let's sub in 0. So what happens when I put 0 into the function? Well, what's -3 times 2 times 2 times 0 minus 6 plus 7. So I'm just subbing a 0 into x right there, right? So you pull out your calculator and you go, all right, we're just going to get an ugly decimal here. All right, so let's see what we get. Let me clear this out from before. Well, just looking at this right here, right? 2 times 0 is 0 minus 6. So it's really just what's negative 3 times 2 to the negative 6 plus 7, right? That's all we end up with. Oops, where'd my calculator go? Here we go. So let's go, all right, well, what's 2 to the negative 6? And we'll just get the decimal of it there. So I got that. Let's times it by negative 3. We got that. And then let's add 7 to it. And we're going to get a pretty ugly decimal number, 6.95. Don't round this to 7 because it doesn't equal 7. Remember, it can't touch 7. So let's just say it's about 6.95, okay? Equals approximately 6.95. So that's where it is, about 0 over 6.95 up. So it's really, really close. It's like right here. Like it's almost touching, right? It's getting super close to that. So that's where our y-intercept is, at 0, 6.95 approximately. So always, you got to calculate that for me. We'll just say it's about that, okay? So my graph basically goes like this. It gets really close, and then all you got to do is just continue it. And basically, it does look just like a vertical line. You could pretty much pull your ruler out, right? It's not technically a vertical line because it's getting closer and closer to that, but the numbers are so tiny, those decimals are so teeny tiny that to our eye, we can't tell the difference, right? All right, what else can we state? Domain. For all of them, x can be anything. The range, remember, y has to be greater than or less than whatever c is. So in this case, y is less than 7, right? I can tell just by looking at the graph. Look, it has to be below 7, okay? 7 is where it can't touch, and since a was negative, it flipped down, right? So there you go. All right, let's just see. Is there anything else we missed here? No, I think we got everything. So there you go. So there's one example. Now, I know I'm going to bore you to death. I'm going to do 4 more. I'm going to move as quick as I can through them, but I really want to walk you through all the different little things to watch out for, and it's going to get pretty repetitive, but for those of you that want lots of examples, here you go. All right, let's do another one with a base of 2, because that's a real common one. So I'm going to do one more with a base of 2. So that's my base there, right? So that is our starting function. We have to identify that or we can't really go any farther. So we're starting with 2. That's my parent function. So you can start with the same coordinates we did before, right? What did I start with? I went -2, -1, 0, 1, 2. Those are usually your 5 stars. You can keep going though with 3 and 4 because sometimes you can sometimes you're going to need those points to find more. And sometimes you might even want to find some on the other side. But you know what? Let's just back it up here and we'll just start with these 5 this time, okay? Now, what happens? All we're going to do is do what's 2 to the power of 0. 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the negative 1 is 0.5. 2 to the negative 2 is 0.25. All right, so there's our starting 5 points. If I need to go back and add some in, I will. All right, so I'm going to try and move as quick as I can. What's A? Because I guess you guys can pause, right, if you need to. I don't need to drag it out. I'm going to go really quick. All right, so here we go. A and C. So A is -1, C is 6. That tells me that there is a vertical reflection. Since it's 1, I don't have to talk about a stretch or compression because it's just 1. Multiplying by 1 doesn't change anything, only the negative does something here. And this is a vertical translation up 6 units. All right, so I'm going to take all my y coordinates and first multiply them by -1. So let's go. All we're going to do is just change these into negatives. -0.25, -0.5, -1, -2, -4, and then we're going to take those and add 6 to them. So it's going to move everything up. Oops, 6. All right, so we're going to end up with 5.75, 5.5, 5, 4, and 2. All right, now the x's, got to make sure that we factor this here. It's 4 times, come on, 4 times x minus 1, right? Got to make sure it's factored. So k is 4, d is 1. So k is 4, d is 1. Now the k, that means it's not 1, so we're going to have a horizontal stretch by a factor of, remember, 1 over k, 1/4. So we're going to multiply all the x coordinates by 1/4, and we're going to have a horizontal translation. Since it's positive, move everything to the right 1 unit. So this is pretty similar to the last one, just with some different numbers. All right, so here we go. Let's multiply all our x's by 1/4. And then let's take those and add 1 to them. So if you prefer to just do it all in one step, go for it, all right? All right, so here we go. We're going to get 1/4 of all of these, right? So I'm taking the x coordinates up there, dividing them by 4 essentially, right? And we end up with -0.5, -0.25, 0, 0.25, and 0.5. And then add 1 to all of those, and you end up with 0.5, 0.75, 1, 1.25, and 1.5. All right, so I've got my coordinates. Let's graph this thing. But before we do that, don't forget our asymptote. It's y equals c, so y equals 6. It's the first thing you want to draw on there. So there's a horizontal line at y equals 6. Here we go. Boom. There we go. Make sure you label it. That's our asymptote. Our line can't cross that. It gets closer and closer to it. All right, I'm going to plot these points the best I can here. So 0.5 over, 5.75 up. It's like right there. What do we got now? 0.75 over, 5.5 up. Man, that's tough, eh? Like right there. They're all squished together. What do we got for the next one? 1 over 5 up, right there. Then we go, oops, 1 over 5 up, right there. Then I go 1 1/4 over, and I'm 4 up, right there. And then I'm, boy, oh boy, right there. Then I go 1 1/2, and I'm at 2. Now, I might want to find some more points because I don't really see a lot of points here, right? So all I got to do is, why don't we just add another one to the bottom of our table, right? So why don't I just go here and add 3, and 2 to the power of 3 is 8. I could even add 4, 2 to the power of 4 is 16, and then just apply those transformations to them and see what happens, right? So what did we do? I divided this by 4. So 3 divided by 4 is 0.75. 4 divided by 4 is 1, right? So I'm just taking these and dividing them by 4. And then I just have to add 1 to them. So that's going to be 1.75 and 2. And then for the y coordinates, right, I'm just, what did I do first? Multiplying by a negative. So this is -8, -16. And then I added 6 of them. So -8 plus 6 is -2. -16 plus 6 is -10. Now that's going to give me an even more accurate graph. Now again, a lot of this comes down to, do I have to do this? Do I have to do that? The point of this is to improve your skills. I'm trying to show you everything I can, right? All the different tricks to get better at this stuff for those of you who want to pursue careers that involve this and be a better mathematician, have better math skills, right? So the answer is, yeah, you should do this, right? If you have 0.0 interest in it, and I don't know, maybe just because you're young, I didn't care about this when I was in high school, okay. But the point is, you want to get better? I'm trying to show you everything I can, right? So 1.75 over, we're 2 down, we're like right about there, and 2 over, 10 down, right? There you go, right there. So this is what my graph looks like, right? Now I'm gonna have a hard time drawing this. I'm gonna do the best I can. I have a hard time drawing curves with this computer tablet graphing thing I got here. Now we don't cross, oop, I'm getting close. Come on, closer, 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 closer. And then I hit it right there. I went off the line a little bit. And then you just basically curve right here and you just go right next to that guy. And that's what this looks like. And they all kind of have that same shape. This one's just a little more squished. And there we go. All right, what's the coordinates of our y-intercept? I'll just write that down here. My y-intercept, set x equal to 0, right? So take your equation and substitute 0 in. So negative times 2 to the power of what's 4 times 0, which is 0, minus 4 plus 6 there. And let's just get our calculator up, right? So again, this is going to be 0 right here, right? This is going to be 0. So it's just going to be what's negative times, you got to do the 2 to the power of -4 first, and then add 6 to it, right? So let's go. What's 2 to the power of -4? There we go. We're going to times that by -1, or just put a negative in front of it, right? And then let's add 6 to it. And we're going to get a really tiny decimal, about 5.9375. Actually, exactly that, right? So I want to be technical. It's really that whole decimal. Oops, not negative. 5.9375. So there's my coordinate. 0 over 5.9375. Okay, so that's that tiny decimal. It's really, really close to 6, right? Remember, it never is going to touch 6. It's just going to get closer and closer. You know, 5.999999, 5.999999. It's just going to get smaller, smaller. In this case, bigger and bigger, but closer and closer to 6, but never actually becoming 6 or touching it. So there's my y-intercept. Domain, again, is just x can be anything, any real number. And my range, y coordinates are less than 6. They can't be equal to it. They just can be less than it. There you go. Okay, I'm going to move on to another one. And hopefully there'll be some little differences now in each one, okay? Okay, I'm finally getting to one where I'm changing the base. Notice the base here is 3. So that's the first thing we need to start with. And people always get confused when they're first learning this. At least I'm just basing on the past, you know what I mean? In the classroom, maybe watching the video and doing stuff on your own or whatever you're not. But they're always lost on what the base is. The base is what the exponent's on, so it's 3. So when I make my starting table, right, I'm just going to start, this is generally what I start with, -2, -1, 0, 1, 2. And then I just go, okay, well, what's 3 to the power of 0? It's 1. 3 to the power of 1 is 3. 3 to the power of 2 is 9. Now, if I need to add more points in, I will. What's 3 to the negative 1? Well, that's 1 over 3. And this is where it gets a little bit messy. I'm going to leave it as a fraction for now because I want to avoid, 0.3 repeating. But you can make it that, though, if you want. Right? You can go like this or 1/3. Okay, let's compare it as we do this, what the benefit is of each. And this would be 1 over 3 to the power of 2, right? So 1 over 3 to the power of 2 would be 1 over 9, right? Oops, hang on. There we go. 0.1 repeating. There we go. So I like working with a fraction personally. I've always worked with a fraction myself, and I just convert it to a decimal at the end, right? But some of you prefer to work with the decimal first, and that's fine. All right, so here we go. What can we talk about? Let's get rolling. Let's identify A is 2 and C is -4. So A is 2, C is -4. There's no negative on the A, so there's no reflection. We just say there's a vertical stretch by a factor, which means we're multiplying, of 2. And there's a vertical translation down since this is -4 units. All right, so I'm going to take my y coordinates and first multiply them all by 2. So again, I'm going to stick with the fraction for now because 2, instead of 2 times this, it's a lot easier to go 2 times 1 over 9, right? And just make it 2 over 9. Okay? And then 2 times 1/3. Well, it's just 2/3. So to me, that's easier, right? 2 times 1 is 2. 2 times 3 is 6. 2 times 9 is 18. And then let's add, or sorry, not add, we're going to subtract 4 from it, right? All right, so here's the part I'm just going to make it a decimal. So let me just get my calculator and just go, all right, you know what? What's 2 divided by 9, right? Okay, we got that. And then let's just -4 from it. Now you're like, well, I want to make it a fraction. That's fine, but we need to graph it, right? So all I really care is it's -3.7 repeating. There you go. So -3.7 repeating. Same with the next one. What's 2 divided by 3, right? You're going to 0.6 repeating, and then -4 from that. And you're going to get -3.3 repeating, right? All right, and then the rest are easier, right? Like 2 minus 4 is -2, 6 minus 4 is 2, and 18 minus 4 is 14. So that guy's not going to fit on our graph. Oh well. All right, let's do the x's now. So we got it. Now here's where we got to be careful factoring this, right? Let me bring this out. You are factoring out -1/2, right? Now it says x minus 2. So you're going to change that to a positive, and the number's not going to shrink. It's going to grow. It's going to be 4, right? Because if you redistribute it in, -1/2 times 4 is -2. So that tells me k is -1/2, and d is -4, the opposite sign there, okay? So there's your k, and there's your d. All right, so k is negative, so that means there's a horizontal reflection. That's the first thing. And the second thing is you have a horizontal stretch by a factor of 1 over k. So we got to flip it, right? So it's really a horizontal stretch by a factor of 2. And it's negative, so we're going to have a horizontal translation to the left, since this is -4 units. All right, so let's do those transformations. So again, when you do your homework, I do need you to give me the, description also, right? Okay, so here we go. Let's multiply our x's by -2, not -1/2, right? So multiply all your x's by -2, take everything here, and times them by -2. So I'm going to end up with 4, 2, 0, -2, and -4. And then I'm just going to subtract 4 from all of those and end up with 0, -2, -4, -6, and -8. All right, it's graphing time. Before we do that, make sure you draw in your asymptote. It's y equals c, so it's y equals -4. So we're going to draw in a horizontal line. There. That's that line that our graph will never touch. It'll get closer and closer to. All right, and let's plot these points on here. So 0 over, now this is, again, they're ugly. I know, just graph it the best you can. 0 over -3.7 down. So right, -3.7 repeating, right? Like kind of right there, right? Just as close as you can. Believe me, I'm not getting out a ruler and measuring here. We just want to get as close as we can. -2 and -3.3, so he's kind of right around there. Now what do we got? -4, -2. It's finally starting to spread out a bit. -6, 2. And -814. So now -814, he's going to be like way up here. So we just want to be mindful when we drop, we're heading kind of towards that area, right? So let's see here. I'll draw like that. Now again, we're heading right close to our y-axis. You really want to get as close as you can without touching it, and it shouldn't start going up at the end. Mine's not perfect, but you get the point. Now again, don't go like this, right? Remember, that next point's up here on this line. Oops, it's right here, right? So, wait, -8. No, it's right here where I had it before. So we don't want to, you know, we basically want to start heading towards that, but we don't want to, right? There you go. Okay, so there's my graph. The good news is we already have the coordinates of the y-intercept. It was on our table, right? With the x-coordinate 0, there it is. So it's 0 and -3.7 repeating over. There you go. All right, domain, x can be anything. The range, your y-coordinates are all greater than -4. They're all above it, right? Because a wasn't negative, we didn't flip down this time. All right, so there's that. I'm going to do a couple more. If you're burnt out and you got it, great. Move on and do the homework. If you want to watch the next two, here we go. Okay, so far I've done them where the base is 2 and the base is 3. Now I'm going to do one the base is 1/2. So there's my base of 1/2, 1/2. Now again, people, a lot of times we get to the test sometimes and students are saying, well, can you give me the table? I don't know what to start with. You got to kind of make your own table, right? What do you have when x is 0, when it's 1, when it's 2, when it's -1, when it's -2? You can always add more in if you want. Like if you want to go 3 and 4, go for it. All right, so 1/2 to the power of 0 is 1/2, but I'm going to write it as a decimal since we're going to be graphing this. 1/2 to the power of 1, oops, I'm sorry. 1/2 to the power of 0 is 1. I'm thinking of 1/2 to the power of 1. 1/2 to the power of 0 is 1. Anything in the power of 0 is 1, right? I should have a bracket around that. There we go. 1/2 to the power of 0 is 1. 1/2 to the power of 1 is 1/2. 1/2 to the power of 2 is 1 over 4, which is 0.25. Then 1/2 to the -1, that flips it, is 2. And 1/2 to the -2 is 4. So go back and look at those original tables. Sorry, a little blip there. I was flipping around by accident. All right, so we got that. We've drawn our first table. Let's do the usual. What is A and what is C? A is 1/2, C is -8, so 1/2 and -8. And again, you can follow along on the handouts I gave you if it's hard to see some of this stuff. All right, so if A is 1/2, that means we have a vertical stretch. Now here it'd really be a compression if you want to be fancy. It's really a compression, but a vertical stretch by a factor of 1/2, right? Because we're going to be shrinking those numbers. And C is -8, so we're going to have a vertical translation down 8 units. All right, so let's take all our y's and first times them by 1/2, and then let's subtract 8 from them. So I'm going to look at these y coordinates here and do that. So 1/2 of each of these numbers are going to get really squishy really quick. So we're going to be having 2, 1, 0.5, 0.25, and 0.125, and then subtract 8 from all those. So we're going to have -6, -7, -7.5, -7.75, -7.875. All right, so they're really squished together. Let's do the x's. Now, again, we got to factor this. Don't forget. So when I factor this guy, I factor out the negative, and I end up with x plus 6. All right, so k is -1. That's the number out front here. In D, we take the opposite sign of what we see, so it says plus 6, so it's actually going to be -6. Now, since k is negative, we're going to have a horizontal reflection, and it's 1, so we don't have to describe any stretch, okay? So you don't have to describe the stretch because it's just 1. And D is 6, it's positive, so we're going to have a horizontal translation up 6. No, sorry, up. Hang on, I just said it's -6, and I wrote 6 here. What the heck happened to my negative? Hang on, fix that. -6, and it's not up or down. That's the vertical one. Moving so quick, I'm starting to mix up things. All right, it's a horizontal translation to the left. 6 units. There we go. All right, so we got to multiply all our x's by -1. And if you're like, well, don't we have to flip it? Well, 1 over 1 is still 1, so we're just multiplying by -1. And then we're going to subtract 6 from them. All right, so all this first does is change the positive and negatives and negatives to positives. So there's my first transformation, and then subtract 6 from everything. And what do we end up with? -4, -5, -6, -7, -8. All right, draw in your asymptote, y equals c, so y equals -8. So drawing a horizontal line down at -8. Boom, there we go. All right, and let's plot these points. All right. So let's go -4, -6. There's my first point they gave me. -5, -7 is right. Oh, I'm lost here. Where am I going? Oh yeah, -5, -7. Right here. There we go. -6, -7.5. Now they're really starting to squish together. Oops. right there, -7, -7.75. Now I'm just kind of getting them closer. I'm not even getting, carried away here. -8's there. Now, this side's easy, but here's where we got a problem. Like, where do I go here, right? You can go like this. Does it look like this? This is where we might want to add some more points to the bottom of our table, right? So why don't we add like 3 on and see what we get, right? Maybe even 4. I'm going to add a couple and see how far it goes. All right, so what's 1/2 to the power of 3? Well, again, we're going to get some pretty... Oh, you know what? I'm thinking the wrong way here. If I add them to the bottom of the table, that's going to be here. That's going to make the points on this side, right? So that's not smart thinking. What I want to do is add some points to this side of the table. Now, I don't have a lot of room here, so I'm just going to write them at the bottom. So what if we make it -3 and -4? That's what I want to do, right? Because I want points over here. All right, so let's make x -3. Because remember, we multiply them by a negative, so everything flips, right? Because why am I adding? Because if it was this way, everything's flipping that way, right? So it's flipping around here. So let's add -3. So what's 1/2 to the -3, right? Well, 1/2 to the -3, don't forget that flips it. It makes it 2 to the 3, which is 8. And then 1/2 to the -4, that's 2 to the 4, so it's 16. There we go. All right, so first we multiply them by a negative, so this becomes, this is going to be 3 and 4, right? And then what did we do? Subtract 6 from them. So 3 minus 6 is -3. 4 minus 6 is -2. And again, these would have normally been at the top of my table up here, right? All right, and what are we going to do? Multiply all the y coordinates by 1/2. So 8 times 1/2 is 4. 16 times 1/2 is 8. And then we subtracted 8 from them. So 4 minus 8 is -4. 8 minus 8 is 0. Okay, so that gives me a couple more points. So let's go. If I'm at -3, I'm at -4. Hang on, -3, -4 right there. If I'm at -2, I'm at 0. So now I'm getting a better picture of what this looks like, right? All right, so it's pretty good. You know me, I want to get carried away. I'm going to even add another point in here, -5, right? So what's 2 to the -5? Well, that's the same as 2 to the 5, which is going to be 32. I really want to get an accurate picture. So I'm just showing you how you can go about doing this, right? All right, so first we times the x's by -1, so that becomes +5, and then we minus 6, so 5 minus 6 is -1, right? And what about the y's? We times them by 1/2, so 32 times 1/2 is 16. 16 minus 8 is 8. Now that's really going to help me finish this off. -1, 8. Look at, now I can really get an accurate picture. Okay, so if you don't have enough points, don't just quit. You can find more points. It only took me an extra minute, right? And that's the point. I'm trying to show you different skills, different things that you can use to do this. All right. So what do we got here? Our domain, right? X can be anything. Our range, look, all our y coordinates are greater than -8. I forgot to label my asymptote here. Y equals -8. And we also need to find our y-intercept. So our y-intercept is going to be when x is 0. So take your equation and sub in 0, right? So what's 1/2 times 1/2 to the power of -0 minus 6 minus 8? Well, obviously, that's just going to be -6. So what's 1/2 times 1/2 to the -6 minus 8? So let's just crack out the calculator and find the decimal value of that, all right? So let's clear this all out. Let's go 1/2 or 0.5 to the power of -6. Gives me 64. Times that by 1/2, or just divide it by 2, right? Gives us 32 minus 8. Boom. Hey, it's 24. What am I thinking? It's not decimal. It's 24. So there you go. 0, 24. So our y-intercept, it doesn't cross this y-axis till way, way up here. Here's 10, right? It's not going to cross it till way, way, way higher up. All right. All right, I'm going to do one more. If you're totally burnt, no problem. I know it's a long video, but I just want to give a ton of examples for those that want it. Okay, final example. Let's start with what the base is. The base is 1/3, whatever the exponent's on, right? So let's write that out. So a base is 1/3 to the power of x. So let's go over here and make a table of values, right? What's 1/3 of the 0 and 1 and 2? And what's 1/3 to the -1 and -2? Well, anything in the power of 0 is 1. 1/3 of the power of 1 is 1/3, or 0.3 repeating. 1/3 of the power of 2 is 1/9, or 0.1 repeating. All right, 1/3 of the -1. Don't forget that flips it, so it just becomes 3 to the 1, which is 3. And 1/3 of the -2 flips it, so it's 3 to the 2, which is 9. All right, so there's a good set of starting points. If you want to graph that, you can. You don't need to. It would look basically like this, right? Again, I'm just doing kind of a sloppy version here, but oops, shouldn't cross that line, but it kind of looks like that. Okay, here we go. What's A? A is what's out in front. A is -1. What's C? Hey, there's nothing back there. So in this case, C is 0. There is no C, right? All right, and D can be 0 also, but in this case, it's not going to be. I see a value up there, right? All right, so since A is negative, it tells us there's a vertical reflection, right? Now, it's 1, so there's no stretch. You're multiplying by 1, which isn't going to change anything. So if you want, you can say there's no stretch, right? No vertical stretch, or you can just leave it blank. Same with this. There's no vertical translation, right? It's not going up or down. Okay, so that means, before I even get going, that means y equals 0. That's my asymptote, right? It's just going to stay right where it started, right here in the middle. It's not going anywhere, right? So, oops, there we go. So it's a little off kilter. Let's just level that off a bit. All right, so right there we go. So there's my asymptote right off the bat. All right, so there we go. So what are we going to do? Multiply all the y coordinates by -1, and then we are going to add nothing to them. So they're not going to change. So if I want to keep my table going, all that happens is all these y values up here just switch from positive to negative. So we got -9, -3, -1, -1/3, and -1/9. And then same thing here. I'm just going to copy them over. Now again, -1/3 is just -0.3 repeating. -1/9, if you go 1 divided by 9, is -0.1 repeating. Okay, there we go. So that's pretty easy. And let's be careful with the x's. So I want to review one more time. What do we do when we have a fraction we're factoring out? Because right now it says 1/3 x plus 1. Well, when you factor out that 1/3, right, what are you left with? It's not x plus 0.3, it's x plus 3. Because 1/3 times 3 is 1, right? So that means k is 1/3 and d is -3. All right, so we have a horizontal stretch. It's not negative, so there's no reflection. Horizontal stretch by a factor of what? Sorry, 3, because we got to flip it. And a horizontal translation by, horizontal translation to the left, because we're moving, it's -3 units. All right, there we go. All right, so let's take our x coordinates, and remember, we're going to flip that k and multiply by 3. So 3 times all our x's. So take all your x coordinates up there and multiply them by 3. So that's going to give us -6, -3, 0, 3, and 6. And then you want to subtract 3 from them. So that gives me -9, -6, -3, 0, and 3. All right, let's graph those points. -9, -9 down here in the corner. -6, -3 right here. This one's stretched out quite a bit, right? -3, -1 right there. 0 over 0.333 down, right? And then 3 over, and it's just getting closer and closer at this point. There you go. All right, so draw your curve through there. And then it just gets closer and closer to that y-axis. And then don't forget, there's an arrow on the other end showing it's going down that way. All right, so there's that one. Good news for finding the y-intercept. It was already in our table. It's right there, right? So the y-intercept is 0 and -1/3, or you can write as -0.3 repeating. Domain x can be anything, and in this case, our y-coordinates are below 0. All right, so there is a ton of examples. I've bored you to tears, but hopefully it helps you graph them. Make sure you try the 4 graphs in your homework and try to do the neatest job you can, all right?